Hello, everyone. Thank you for taking time to be here today as I share my students' work on investigating aquatic ecosystems with computer vision, machine learning, and the Internet of Things. I'm Kenneth, a research scientist at the National Institute of Education, Singapore. It's my pleasure to be a part of Show and Tell EDUtech Asia 2021. Our story begins in a regular state-funded school in Singapore. Like many schools, the school has an ecologically themed area, in this particular case, a school pond. As my students walk along the pond in their daily interactions, they started to notice something peculiar about the pond. So here's another shot of the pond, and you can see that the ends of the pond are separated by a narrow channel in an S shape. What my students noticed, which aroused their interest, was that the fish in the pond tend to gather at one end of the pond as opposed to the other. So this sparked their curiosity. Curiosity is an important part of my team's work because our wider focus is surfacing the intuition of learners through phenomenological means. What my students decided to do was to investigate why this might be the case. They started with prototyping on paper. Their first iteration was to take apart a robot submarine with the intention of hacking it, such that it could be used with sensors to take readings from around the pond. However, we soon found out that the components of the submarine were not very hackable. We therefore decided to custom design our own kit. Here's a schematic of the various sensors indicating the variables which our students decided were important to measure. So for example, we have acidity, alkalinity, pH, turbidity, water temperature, and dissolved oxygen. They are connected to a microcontroller. The microcontroller is of course delicate and needs to be kept dry. Here we see the components within a box which you might buy from a supermarket. However, of course, it wasn't as straightforward as that, because we needed also to measure the quality of the water, and thus we had to hack the box to make sure that the cables could be trailed out of the box to measure the quality of the water. So this posed a problem. On the one hand, we needed to keep the components inside the box dry, while on the other, we needed to measure the quality of the water. So my students came up with this idea of taking a pipe which they had found from a workshop and cutting it and designing a cap, which on the one hand could allow access to the components on the inside, while on the other, keeping the components inside waterproof. On this cap, they also placed a glass dome. Perhaps you could think about the purpose of the glass dome. So here's a picture of the whole pipe assembly with one of my students holding it for scale. This picture shows how the sensors protrude through the pipe through holes drilled by my students. The black represents our attempts at sealing the pipe and making it waterproof. Here's a good picture showing the sensors as well as the dome. Have you guessed what the purpose of the dome is yet? Well, to give you a clue, here's the dome without the pipe, and you can see that it trails off certain pieces of equipment from it. Here's the dome, this time attached to the pipe. You can see the microcontroller behind it, and you can also just make out a camera. So yes, the purpose of the dome is to allow the camera to take photos of the fish, because what we were planning to do is to train a machine learning model on photos of fish taken underwater so that the fish could be counted and then the counts correlated against the quality of the water. Here's a schematic showing the entire assembly. From left to right, we have the container for the electronics, the sensors, and the camera dome. Now, once we had this assembly, there were other parts of the process which we needed to learn about. Thus far, we had been learning about design, electronics, coding, artificial intelligence, and engineering. We then had to learn about chemistry, because in order for the sensors to measure the acidity or alkalinity of the water, they first had to be carefully calibrated. We could not do this on our own, so we sought the expertise of a chemistry teacher who helped us calibrate the instruments from known quantities of pH. So what I like about this project we are sharing today is that basically it was an integrative project sparked by the students' own curiosity and through which they learned many things from different disciplines such as chemistry, engineering, coding, artificial intelligence, and so on. Now, once everything was set, it was time to test the equipment. The next few photos show us determining the feasibility of using computer vision to count the fish in the pond. To do this, we put a smartphone into a regular box and we launched it into the pond. Using the timer of the camera of the smartphone, we took a few photos. However, we soon faced a new problem. Each time we placed the box in the pond, the fish would swim away in the other direction. This was a classic example of Heisenberg's uncertainty principle, in which the very act of observation changes that which was being observed. As if that weren't enough, we also had to stabilize the box because the box kept bobbing in the water. So what we did was we used rocks that we could find in the garden in an attempt to change the center of gravity of the box so that this camera in the box could be held upright and stop bobbing around. We tried putting rocks both inside as well as outside the box, and you can see that we went through a few rounds of testing. Here's a shot which clearly shows the smartphone camera within the box. Having spent a tiring day testing the computer vision, we then decided that it was time to seek professional advice on how to waterproof the pipe. So for this, we went to the Institute of Technical Education in Singapore, which is a vocational training institute, and we explained what we wanted to do to the very helpful staff, and she helped us to connect with her colleagues who had expertise in waterproofing. While we were there, we also discovered that the institute staff were interested in a similar problem, namely measuring the water quality of a fish tank. Here's a shot of one of my students cradling the pipe as we listened to the member of staff of the Institute of Technical Education explaining the technicalities of the setup in their pond. After a few days, the Institute of Technical Education returned the pipe to us, and here's the before and after. You can see that they really did a terrific job of helping us seal the pipe professionally. So that's been our progress thus far. This project is still ongoing. I hope you have enjoyed our sharing today. What we've been trying to convey to you is that sometimes really interesting inquiry experiments can be triggered by our students' own observations of everyday phenomena. And if we were only to make time to listen to them as to how they understand and interpret the world, we would actually be able to learn a number of things from them, as well as helping them to learn about their local environments. Thank you very much.